So in this video, I'm going to go over how to replace a broken keystem on an Apple IIe keyboard with a 3D printed alternative like this one right here. Now, I should note that this is one of several different types of keystems that you'll find on Apple IIe keyboards. This is specifically known as the long SMK style keystem. There is a short SMK that is combined with the blade style, and then there's the longer blade style as well. And we're not going to get into those here, certainly. But we will cover this style, which is a pretty common style that you'll find on Apple IIe keyboards. Now, before we get into it, just one thing to note: if you've never torn down an Apple IIe before or taken apart the keyboard, it's important to understand that the Apple IIe keyboard only comes apart so far. I mean, obviously you can take it out of the unit, you can pull the keycaps, but the PCB and its frame are pretty much inseparable. The key switches are soldered through the frame and through the PCB. And so the solder joints on the key switches are really what's holding the PCB to the frame. Now, you may have, you'll see that there's these screw holes here, and in my case there's no screws in it. But you may have screws in some or all of those holes, and if you do, understand that removing them will not help the situation at all. Those screws are really there to provide structural support so that they're actually taking the load instead of the solder joints, because solder joints really aren't intended to be structural joints. They're intended to be electrical joints. So those screws are purely for reinforcement purposes. They don't actually, removing them will not actually make removing the PCB any easier. But in all honesty, you shouldn't need to, because the only thing on the face of the PCB that you can't get to is the connector itself, which is on the end here. And then you'll see that there are 10 solder connections in 2 rows. 2 of those are I think 670 ohm resistors, and I think the other 3 are typically just pass-through wires. So you should really never need to actually get to the top surface of this PCB, but if for some reason you think you do, you're going to have to desolder every single key switch on this keyboard. So anyway, what we're going to do though is we're going to replace this broken keystem with a 3D printed alternative, and to begin doing that, we simply need to desolder the existing keystem. So our keystem here is on the end. So we flip it over and we find the nearest number to that, and we see here it's number 1. I believe this is the escape key. And the soldered connection immediately next to the 1 is one side of that keystem, and then the soldered connection nearest it is going to be the next. So you can see that as you go across these numbers, you see that there's pairs of solder connections which represent the 2 connections to the key switch. So what we want to do is we want to desolder these 2, and the easiest way to do that, of course, is with a desoldering gun like I've got right here. This is just a cheap gun that I've gotten off of AliExpress. You can also use desolder braid and a soldering iron if you don't have a desoldering gun. But I highly recommend, if you don't have one of these, I highly recommend getting one, because they don't cost an awful lot and they work pretty well. So let's take out that key switch. Alright, once you've desoldered the key switch, you need to make sure that the leads on the switch are not still connected to the pads by a strand of solder that didn't get removed. So it's important just to kind of take your finger and just push them a little bit and make sure they move. And there I heard it pop a little bit, so I broke loose an old piece of solder, and sure enough I feel the other one move. So I know my key switch leads now are free, so that when I try to remove the key switch it'll come out. And that's important, because removing these key switches, it shouldn't be difficult, but it's a lot harder than it looks sometimes. The key switches have, I'll tip this up so we can see it better, on either side of the key switch is a tab that pulls inward, and they're a little bit tricky to maneuver in order to pull the key switch out. So what I'm using is a long pair of tweezers that came with my 3D printer. They're quite handy, and I'm pulling them and I'm using them to squeeze in the tabs. And then if you're lucky, you can just pull upward, and sometimes they need a little bit of wiggling. This certainly does. And you can see then that the tweezers kind of fall off those tabs pretty easily. But a little bit of wiggling sometimes is all that's necessary to break that loose. Here I'm kind of prying under the corner of the key switch with my finger, with my fingernail a little bit, and it is wiggling loose, and there we go, I've just popped it loose. Get it back in the light again. There we go. Just popped it loose and I slide it out. And there we go. I've got my key switch free. Now, when you take a look at the key switch, you can see that there are, get it up in the light here, you can see that there are the two tabs that held it into the hole. These two tabs also hold the switch top and switch bottom together. And so removing them, you'll see that there is a joint right here where the bottom joins to the top. And then removing them simply means taking this tab and pulling it back and prying it loose. Okay, so we'll just kind of rotate that and try to get it in the light. I don't have very good lighting here, so it's kind of tricky to get a good angle. But if we pry it just a little bit, you can see that it's popped loose on the one side, and then I'll just take this and pry on the other, and now it's come loose. They usually don't come open that easy, to be honest with you, but in this case I got fortunate. But what you got to do is you just got to pull those tabs back, and then you'll have to work at wiggling the bottom loose to pull it free. And then you just want to hold the bottom and top and just kind of carefully pull them out. All right? And just be careful because there are several loose pieces that could easily get lost if you're not careful. All right? So what we have in here in the center is a spring that goes in the middle of our key stem. We'll set that aside for the moment. And then we have, in the key switch itself, the two contacts. Now the two contacts, normally they should stay in place. And you shouldn't need to remove those, or you shouldn't have to, you should not have to pull them out of the top case. They should stay mounted in the bottom case. If not, and they stay stuck in the top case, then you'll have to pull them out gently, maybe with a pair of pliers or something like that. But the two, note how those two contacts, they're two separate pieces of spring steel, and note how they are organized. Okay. There is, in fact, you can tell if you take a look at each piece, there is at the very tops of them this copper color, and this is where contact is made when the key is pressed. And what happens is, when the key is pushed down, when the key is up, there's a little tab, a little bump built into this piece here. If I pull it out a bit, you can see that right there just underneath my finger. And the width of the key stem pushes that back, preventing contact. And once you push the key down, that flips forward and these two pieces meet, and that makes connection. So note how this is mounted in the bottom case, because if they come out, you may have to remount those. Okay. Also note that these go in one specific side of the top case. If we take a look, you can see, get the light on it here just right. If you take a look down here on the bottom side, you see that there is a wider slot with two small pieces of plastic on either side that split it in half. Those two pieces of plastic are dividers that slip between those two contacts. So we need to make sure that the back contact goes in the back half of that slot, and the front contact goes in the front half when we put this back together. Now, my key stem just kind of fell out. They may not, they may stick a little bit. So if they do, you just kind of push them back out through the hole. But once the key stem comes out, replacing the key stem is really quite straightforward. So now we have to mount the key stem inside the switch. And there's this particular way where it goes. If you take a close look at the key stem, you'll see that it has a side with two sides of the key stem are beveled and two sides are flat. Okay. If you take a look inside your key switch, in the top case of the key switch, you've got these two round pockets on either side. The flat sides of the key switch, not the beveled sides, the flat sides, as I've got it turned right here, fit in those two pockets. So we put it in like this. Okay. So there you can see there's my flat pockets. Try to find that light again. There we go. There's my flat pockets going in the rounded pockets there inside the top case. So once you get it in there, you might have to push a little bit, but it should pop into place. And then you can feel it, and then you can sit here and work it back and forth. And that'll be, of course, the final test to make sure it moves freely, and in this case it does. So that should, whoops, that should work pretty well. Put that guy back in. There we go. So when we're reassembling the key switch, then we start by putting the spring in the bottom of the stem, and then we need to align the spring steel contacts on the back of the bottom case with the divided slot in the back of the top case. Okay, and at the same time, the spring has to catch on that little nub there in the middle of the bottom case. So it has to be done fairly carefully. But once you get that aligned, and then you turn it sideways and try to and work to make sure that the spring steel is separated by that divider. Okay. One other thing is that there are these two vertical uprights here, which are part of the I think part of the leads on the poke through the bottom case. They can catch on the edge of the top case and then get bent backwards. So it's important to make sure they're tucked in so that they slip inside the top case. So we just kind of gently work it back and forth, and we can see that the spring will pretty much take care of itself. I don't know how visible that is. It's not really great in this shot. But the spring can pretty much take care of itself. Mostly what you need to be focused on is ensuring that the spring steel contacts slot properly in the back of the top case. And so then we just slowly work it forward, and you'll hear the side clasps pop. Now in this case, the one clasp popped, the other one is not yet. You can see there's a slight gap in the bottom, and the clasp is still out. So we just push a little harder, and there, that clicks in place. And now I've reassembled my key switch. And if I press it a bunch of times, I can feel it working. And it's important here to do some tests. And it's important here to make sure that that the switch feels correctly. If it rubs too much and it doesn't rebound correctly, then you need to disassemble it and sand that shaft just a little bit more to get it right. And these could be manufactured with a narrower barrel. They absolutely could. But the risk there is that in the printing tolerances you might end up with too loose of a fit, and then you'll have a key that's too sloppy in the hole. And to choose between the two, I would rather have to do a little extra sanding to get the fit just right than have too loose of a fit that can't be corrected. So with a little bit of work, this is now moving correctly. And now we need to reassemble the key switch by putting it back in its spot. Note where the positions of the leads are on the back of the key switch and where the holes are in the PCB through the frame. So we just make sure that they line up, set the key switch in the hole. At this point, it's important to flip the keyboard over and take a look and watch in the back holes to make sure that the leads are coming through. And in this case, I think, yes, they are. So my key switch just locked in place. The tabs are now locked in. And if you sit here and if you work the two key switches, they should feel identical. There really should be no difference in the feel of the replacement key switch with the original. The other thing to check, and this really should not be an issue either, but it's important just to make sure, is that the heights are equal. Now, these key switches over time, they're not going to be perfectly level. They're never going to be perfectly level. But at the same time, you do want to make sure that there's nothing wrong, that you don't have a height issue, and you really shouldn't with the replacement key switch over the surrounding ones. Once that is done, now you can reassemble your keyboard and put the keys on. But I always like to do a quick little test, and so we will. Our key switch, our replaced key switch, is this one under my thumb here. So I find it, and I put my finger on the back, and I find the two nodes, which in this case it's pretty obvious since they're not soldered. But it's just gotten to be a habit for me. And we'll put this here so I can see more easily. So these are my two nodes, and what we want to do is we want to make sure that we're getting contact when the switch is depressed. I've got this set up right now, and we'll test on a switch that's soldered in first. So if I touch a couple of these soldered nodes, you'll see that I get infinite resistance. It's an open circuit. So if I push it down just a little bit, there you see that my switches make contact. Okay. So now I'm going to do the same here. I'm going to find my two nodes. I've got infinite circuit. Push it down. Sure enough, I've made contact, so I know that once I solder this switch in, it's going to work. So we'll get our meter out of the way. And get my iron, which is heated up. And we'll get this soldered. Oh, that wasn't enough. There we go. And then there. Connection has been made. And that is how you replace an SMK keystem on an Apple IIe keyboard.